here's the way our lessons are going to go. Normally, you're going to be given one of these pages, and I'm going to work through it with you. I don't do it exactly the way A+ wants me to do it. This is supposed to be designed where you answer this on your own, and then I come back and talk about it and correct it. But that seems to not work very well for our math students for whatever reason. So I'm not going to do that. I'm going to work through this with you. And then you'll see on the second page, there's a place where we can like formalize what we've learned. So like make some notes. And then there's a few of these for you to try. So our goal is every day we get finished with the front and you can do the check your understanding in class before you leave. And then we might have a few days built in to do your Canvas stuff, but it may be a lot of stuff you're going to have to do like for homework. Okay, so that's, again, it's tougher this time of year. After Christmas, you will have time in here to work on Canvas. But this module 2, 3, and 4, it's cram-packed. So I'm going to do as best I can to give you time in class, but I'm not guaranteeing it. Okay, so anyways, so let's read the situation and then we will fill this out. Can we predict the maximum heart rate? Understanding heart rate can be an important tool for your own personal exercise, training, and for monitoring your cardiovascular health. One measure that is often calculated is your maximum heart rate, which they're going to call HR max. Your maximum heart rate depends on your age. The table below gives data about the relationship between age and HR max measured in beats per minute. Can you describe the relationship between age and maximum heart rate?
As age increases, heart rate decreases.
I'm good with that. As age increases, the maximum heart rate decreases. Can everybody see that from that table? I hope you can. Some things we want to fill out here on the table. This first column for the age, this is our input to a function. And the HR max is like our output. Does anybody know what we call the input and output formally? Yeah, we're working into functions. The independent and the dependent. That's also, we're going to talk about that in just 1 second. So you're a little ahead. We call the inputs our x, right? And we call our outputs the f of x. So you guys are used to calling it y, right? But you're moving out of that talking. This is just y. That's all it is. But we're going to give it a formal name of f of x. That way I know I'm talking about a function. So if we are talking about functions, I guess we need to make sure we have a definition for what a function is. Oh, that is not acceptable. I appreciate that. That is a way to tell if a graph is a function. But when you take the AP exam, they're going to ask you a word problem to determine if this is a function or not. And if your answer is it's a function because it passes the vertical line test, you do not get credit. So that is not good enough. Even though that is true, functions do pass the vertical line test, you've got to know more than that. Have any of y'all ever had me for a math class before? Jason did, and yeah, Jackson. Not math. You had me for computer science, right? Was it Algebra 1? Then you should know what a function is. I started every day for a month making people say a function. When I say this definition, you're going to be like, oh yeah, I remember him saying that.
Oh, every input has exactly one output.
A function is a special relation where every input, and what's another word for input? X. Every input has exactly, I didn't spell that correctly, one output. Every input has exactly one output. Every X has exactly one Y, which is why it does pass the vertical line test. Because every X only has one Y. Okay? And if I had you for Algebra 1, I mean, again, I say that every day for a month. I say, what is the function? I don't remember. Can you tell me what that is? So, it's important, and it's going to be important in here. You've got to know what a function is. Sweet. And then let's talk about one more. This one is not, I don't like this one as much, but Cooper likes it, so. Let's talk about independent and dependent variables. Because we do have to talk about it. I don't use it often. Here's the way I think about independent and dependent. When you're independent, you get a choice. Right? You can do what you want to do. So in math, the independent variable is the variable that we choose, that we can select, whatever. And the dependent variable is what happens as a result of that choice. So for us, the independent variable in math is x, because we get to choose the x. And then whatever gets spit out, or whatever the output is, which is our f of x, is our dependent variable. So in this particular instance, age is the independent variable, and the maximum heart rate is the dependent variable. Here's a way you can check. Like, we're going to do some problems later, I think, in here. Maybe it's Algebra 1. Where I give you two variables, and you have to tell me which is independent and which is dependent. Here's the way I test that. I don't have a better way than this. I read a sentence out loud and see which one makes more sense. It's not very mathematical. I wish I had a better way. But here's an example. If I'm looking at age and maximum heart rate, I will say your age depends on your maximum heart rate. And then I'll flip it. I'll say your maximum heart rate depends on your age. Which one, to me, I can just tell which one makes more sense. Does my age depend on my maximum heart rate? Nope. Does my maximum heart rate depend on my age? Yes. So the maximum heart rate depends, it's the dependent variable on the age. Okay? And that's the way I can determine, if I'm given two variables, which one's independent, which one's dependent. All right? Just a little trick, a little tip. If you ever have time, it's going to be X. If you ever have money, money's going to be Y. And this is true like 99% of the time. Almost every problem you're going to have is going to have one or the other. Time or money. Guess what we had in this one? Age. Well, age is just basically a measure of time, which is your X. Again, they don't always have time or money in them, but I'd say 60% of the problems are going to have one or the other. And 99% of the time, time is X when you do have time. And 99% of the time, money is Y. So, everybody good with that? Those are a lot that I had to throw out there. Right? Lots of definitions. Let's just keep moving. 2, or B, predict the maximum heart rate of a 35-year-old. Oh gosh, I'm almost 35. I'm so old. 185? About 185. Now the second part, explain.
it's in between 40 and 25.
Okay, so I like both of those answers are fine. It seems to be decreasing. I'm gonna do both. You can choose either one. Seems to be decreasing by 1 beat per minute each year. I like that. That's fine. That's a fine answer. Or the other one said something about between 195 and 180 because it's decreasing on that interval. It keeps going down, and it has to be somewhere between there, right? So 185 is not necessarily the exact answer, but it's good enough guess. That's all we need in this situation. We good with that? 2. Let's look at the graph this time. Oh, gosh, what did I do? Stop. There we go. The graph also shows this relationship. So they've graphed it. That graph looks linear. What is the maximum heart rate of a 60-year-old? 160. Thank you. How did you get that? Thank you. You go to 60 and you went up to 160. Now, what I'm going to do is I'm going to write this formally. What we really did was f of 60 equaled 160, right? I went to 60 on the x-axis and it spit out 160 as the y value. Everybody okay with that? B, what age would you predict for someone who has a maximum heart rate of 200 beats per minute? So here I'm going to 200. I'm just looking, where does it intersect my line, right? And it appears to intersect it about here at 20. So we would say 20 years old. All right, here's the one people just really have, I don't know. What I was asking, where is f of x 200, right? Where's the y value 200? And I found the x value is 20. So here I was given the x, asked to find the f of x. Here I was given the f of x, asked to find the x. C, write an equation that can be used to determine the maximum heart rate of someone who is X years old. Okay. Did you immediately have a panic attack when you saw that question? Did that like jump up in level for you a lot, or you still feel? I'm just trying to get a gauge because y'all been talking about how easy it was, and I'm just curious. Equation. What's an equation? Math statement with an equal sign. So I need something equal to something that can predict the max heart rate of someone who is X years old. It's not a ghost, I promise. It's just cleaning itself. It's all good. It's all good. Or maybe it's printing something from who knows how long ago since I turned it off and back on. You know what? Maybe there is a ghost. I don't know. Anybody got an equation? That is an equation. But it doesn't fit what we want this time. Because what you're saying is, if someone is X years old, so if someone was 30 years old, then you're saying their max heart rate is 30. Right? If someone was 90 years old, you're saying their max heart rate is 90. Yep.
HR max equals x times 1, negative 1 beat per minute.
The negative 1 beat per minute is not bad. It's not bad, but that's not what we're looking
For going off of, it's losing 1 BPM every year, just do 220 minus X.
Which is the correct answer. How did you get there?
I just added 14 to 206 up here on this data thing.
Okay, so he looked at the table and he said if a 14-year-old is at, if a 14-year-old was at 206 beats per minute, then a 0-year-old would be at 220, right? If they're going to add 1 every year, if we were subtracting 1 the other direction. And so when you're 0, when your age is 0, we want you to have a max heart rate of 220. But if your age was 1, you would subtract 1. If your age was 2, you subtract 2. I guess you just reason through it that way? Yeah? There's a much easier way that we just, for some reason, you haven't taken your Algebra 1 and you married it to. This is a linear relationship. How do you know it's linear? It's a line. Okay? Pre-cal is all about stuff that's not straight lines. So we're fixing to ramp this up and do lots of graphs that are not straight lines. We've got to make sure we know the basics from the beginning, which is equations of lines. So how do I get an equation of a line?
Y equals mx plus b.
Slope-intercept form. That's what you learned originally. So I need 2 things to make this equation. I need the slope and the y-intercept. What's the y-intercept? It's where it crosses the y-axis. It crosses the y-axis at 220. And then what's the slope? Slope is
Now my shit is decreasing each
negative 1. It is the rise over run. It's the change in y over change in x. Delta y over delta x. Slope formula, y2 minus y1 over x2 minus x1. How does slope show itself on a graph? It's the tilt of the line. So if it's tilted up, that's a positive slope. If it's tilted down, it's a negative slope. We read graphs from left to right, just like we read words. So from left to right, this is going down, meaning it has a negative slope. And you guys said we were going down by 1 beat per minute. So in your slope-intercept form, this would be negative 1x plus 220. Right? What's negative 1 times x? That's just negative x plus 220. Which, what did we say the answer was before? It's just flipping this around. It's just not in slope-intercept form. They just done it opposite. They put the y-intercept and then put the y-intercept. That's all it is. So anytime you're asked for an equation of something that's linear, you need to go slope-intercept form. Can I find the slope? Can I find the y-intercept? Good, good, good. Sweet. D, what do you think are reasonable values for x in your equation?
2.
Huh? 2?
Yeah.
Do y'all think 2 is a reasonable x? I think so. I wouldn't write. They want, what do you think are the reasonable values? Not just, you don't have to list them, but just give me like a, under 100? Why? Okay, so under 100. So what you had to know to answer that question is, what did the X represent? X represented age. And so it makes sense it should be under 100 because death. I don't have enough room. Y'all can do better. Okay. That's a good start, but I want a little bit more.
Any real number.
No.
It can't be negative.
There you go. That's the other part. Negative 37 is my x. That's under 100, right? So we could say,
Positive number under 100.
I'm going to change this to between, yeah, that's fine. That's fine. Positive number under 100 is fine. I'm going to go between 0 and 100 because that, though I can leave mine. I could put because birth and death. That's the reason doesn't really matter. The thinking's what I care about. Could you give me a list that is all the possible inputs? Did you hear what I just did? Oh gosh, all the possible inputs, because these are x's are inputs, and I'm going to list all the possible inputs. What's the name for all possible inputs?
Any real number.
No. Domain. Do you know that? Domain is the list of all possible x values. Yeah. So the domain here, let's be very mathy then in our answer. The domain is all x's such that x is less than or equal to 100, but x is bigger than or equal to 0. So my x is between 0 and 100. Hey, look, compound inequality. Y'all did that in Module 1. Y'all all did so great on that. I'm sure you're upset, right? You good? Everybody good with that? E, do you think it's possible to have a maximum heart rate of 100 beats per minute?
No.
Why or why not?
You have to be 120 years old.
125.
I'm not documenting anything about other people do 120. Walt Disney is crown frozen 7 days.
He's not. That's a lie. Don't lie. So that's fine. You can answer this any way you wanted to as long as you backed it up with a correct answer. So if you said no, because to have max heart rate of 100, dude would need to be 120 years old. All right. And so you could say, ain't happening. Or you could take the other side of it and, like, if I was answering this, if they said, do you think it's possible to have a maximum heart rate? My answer would probably be possible, but extremely unlikely. Right? There might be 120. I mean, there's like people that will be 107. I don't know anybody that's quite 120, but I mean, I'm not making it that far. I'm not healthy enough. But you get the moral or the big, anyways. Yeah, it's every one of those people that they ever interview that's old is like, what's the secret to living so long? It's like, I had a Dr. Pepper a day. And it's like, what? There's no way that worked. Are you kidding? 3, while the formula found above was easy to use, researchers found it to be less accurate for women. They proposed the function h of x equals 206 minus 0.88x to estimate the maximum heart rate h of x for a woman who is x years old. Find h of 32 and interpret your answer in the context of this problem. So I want to give you a minute, see if you can do this without me, and then we'll talk about it. So hopefully this has been a good lesson for you that's been mostly review-ish. Maybe function notation review, linear equation review, domain and range. So again, remember this is normally the day 1 lesson for pre-cal. So they're just kind of introducing you to what we're doing. So it's supposed to be nice and gentle to start. So hopefully you feel that way. Do we have our answer? What do we get?
177.84.
Anybody confused how to get that? So what did you do? Let's just write it out so we all can see. You subtracted by 0.88 times 32, right? You substituted in 32 for x into that equation. Now, it says interpret this answer. So that means just tell me what this means. If h of 32 is 177.84, just tell me that in words like you're in an English class.
When they're 32 years old,
Who?
when women are 32 years
When a woman is 32 years old, okay?
old, average heart rate is 177.84.
That's right.
Or maximum heart rate.
That's right. The maximum heart rate should be 177.84. Everybody hear that answer? I don't feel like writing that one out. That's too long. Right? But could you do that? Could you interpret that from math words to English words? That's a big deal in AP Pre-Cal. Okay? Making sense of it. Can you, it's more than just giving me the number answer. It's give it to me in the bigger context of everything we're looking at. Okay?